Hello, chemistry. Welcome back. Our wintry mix for the week did pull through, so maybe next week we'll only have one e-learning day instead of two. Anyway, so yesterday what I wanted you to do was take notes over slides 8 through 11, so I'll go over those real quick, and then I'll show you what I want you to do today. So remember, we've been talking about polarity. Some molecules can be nonpolar and some can be polar. That only applies to covalent compounds. That has to do with a difference in electronegativity, which is how strong an atom or how likely an atom is to draw electrons to itself. So what we noticed is the smaller elements tend to be more electronegative, the larger elements tend to be less electronegative. So in order to be nonpolar, you got to be in this range. Polar covalent, if both are nonmetals, would be 0.5 to 2. Anything at 2 or above, if it's a metal to a nonmetal, it is ionic. So now we're going to be talking about bond dipoles. What that means is it's a measurement that shows how polar a molecule is. It occurs when there's a separation of positive and negative charges. So what that means, if we go back to the PhET really quick, okay? If we go back to the PhET, when it loads, if you can remember that black arrow that we had, okay? Here, I've got molecular dipole and then bond dipoles, okay? So here's what I want you to notice. Atom A is less electronegative. Atom C is less electronegative. Atom B is slightly more electronegative than the two of them. The black arrows are called bond dipoles, and that's showing the direction of the most electronegative atom. So if I drastically increase this, notice how much bigger the arrows get. It's measuring where the electronegativity is. Now, if there's less of a difference, notice how the arrows get smaller. That's a smaller dipole. There still is a slight pull over here on the electrons nearby, but it's a lot less significant if I were to do this, okay? If I make them all equal, notice that the arrows disappear. So I could literally put all of them in the middle and there would be less of a dipole, okay? If I make A and B more electronegative, notice how all of the electrons are going this way, okay? So this occurs in atoms that have a higher electronegativity, so they're going to have more pull. The greater the electronegativity difference, the larger the dipole, which is what I just showed you, okay? So you're going to draw a dipole or an arrow when there is an unbalance of charges between atoms of a covalent bond. So if you draw a molecule where, let's say, atom B is super electronegative and the other two aren't, you would draw the arrows, the dipoles, pointing towards letter B because it is the most electronegative. This is where most of the electrons are going to be hanging out in this molecule. Okay? So bond dipoles only exist for polar bonds. The arrow points towards the more electronegative element. So if these were two chlorines bonded together, there wouldn't be a dipole. They're the exact same. But since hydrogen is a lot less electronegative than chlorine, the arrow points this way. So this means this has a slight positive charge over here. This has a slight negative charge over here because the electrons are going to be hanging out over here more. So this is just more practice from in your packet. So what I wanted you to also do yesterday is work through at least 4 of the problems on page 11. So 3D drawing for chlorine, I can't really do it on here because I'm typing, but this is 2 chlorines. This is my very poorly done drawing of chlorine. It's a straight line, y'all, so it's not going to have a 3D drawing. Remember, the only things that have 3D drawings are tetrahedral structures. When this says work/calculations for polarity, you would just figure out what is the electronegativity of chlorine to chlorine, and you would subtract. When it says type of polarity/bonds, you would say it was non-polar because it's going to end up being 0 since it's chlorine to chlorine. If you're confused as to, I don't know, where to find these, go to your gold packet. Maybe. And it's page 4. That's going to tell you the different electronegativities of the elements. Okay? So a different one that might be a little more challenging would be one like CH2Cl2. Okay? So I'm going to have a couple different bonds here. I'm going to have a carbon to a hydrogen bond, but I'm also going to have a carbon to a chlorine bond. We'll have 2 of each, but I'm not going to write the same thing twice. It doesn't make any sense. Okay? So here, when it says work/calculations, you would take whatever the electronegativity of carbon is, which is 2.5, minus 2.1. And that equals 0.4. Okay. And then if I take whatever chlorine is, so chlorine's electronegativity is 3.0, carbon's is 2.5. So remember, it's the higher number minus the lower number equals 0.5. So this one's kind of confusing, right? It's made up of both kinds of bonds. It's made up of nonpolar bonds, since this one's at 0.4, but carbon to chlorine is 0.5. So what I want you to start noticing is that in one molecule, you can have polar and nonpolar bonds. If I Googled a picture of what this looks like, CH2, Cl2. Wow, what a pretty name. So if you look at the 3D drawing, it's going to pop up here. This is a polar bond. This is a polar bond. These are more nonpolar. So if I were to draw a dipole for this, I would be pointing this way in my molecule. I would have a black arrow pointing up towards the 2 chlorines and away from the hydrogens because the electrons are going to be hanging out on the chlorines a lot more. Okay? So for today, what I want you to start doing is work your way through this PhET. Okay? Using the link here, following the directions, I would like you to complete the PhET. I would also like you to continue practicing this. I can post an answer key here later on today, just so y'all know what you're looking at. And then I would also like you to complete the PhET. We are going to be a little bit behind because we'll do page 13 and 14 together in class. If you are really that bored and you want to work through them, go for it. But I'm not super worried about that. And then, how much of the slideshow is left? At least start writing down the polar versus nonpolar notes. So that would be slides 12 through 18. Okay. So these just give you really good examples. If you're confused, if you don't need the examples, don't worry about it. Okay. Just take notes on the slides that have actual typed text. Okay? So your goal for today is double check your practice up here, complete the FET, take notes on at least slides 13 through 16. I would recommend getting the examples in your notes, but it's not necessary. Okay? Let me know if you have any questions, and I will be happy to help.